This video we will going to see about that assembly line balancing problems. See, this is the example sum of that assembly line balancing. A small electrical appliance is to be produced on a single model assembly line. The work content of assembling the product that has been reduced to the work element listed in the table below along with the other information. The line is to be balanced for an annual demand of 100,000 units per year. The line will be operated 50 weeks per year and 5 shifts per week and 7.5 hours per shift. So the annual demand here they given 100,000, 1 lakh units per year. They will produce 1 lakh units, 1 lakh products. Then the line will be 50 weeks per year and 7.5 hours per shift. One shift is 7.5 hours. Manning level will be 1 worker per station. Previous experience suggests that uptime efficiency for the line will be 96% and repositioning time lost per cycle will be 0.08 minutes. Now they ask to determine the total work content time and the required hourly production rate, cycle time and service time. One by one we will see. See, this is the tabular column given. There's the numbers and this is the work element description. Place firm in work holder and clamp. Assemble plug government to power cut. Assemble brackets to frame. Wire power cord to motor. Wire power cord to switch. Assembly mechanism. These are the work elements. And TEK minutes. For these activities, it will take this minutes, 0.2 minutes. Place frame in work holder and clamp, it will take for 0.2 minutes. And here it is preceded by, which means here there is no precedence, that this is the starting stage of that workstation. And also here also, this is the starting stage of that workstation. Assembly plug government to power cord. This is also starting stage of workstation. And that assemble brackets to frame. This is the 0.7 minutes. It is preceded by 1, which means if this activity will start only if it is finished by that the work element 1. Likewise, see here the wire powder cord to motor, it preceded by 1, 2, which means it should be start wire power cord and to motor should start only if it is this 1 and 2 will be finished. Likewise, they will give that predecessors. This is the predecessor for this activity. If it is finished, then it will start. If it is finished 3 and 4, then this will start. Likewise, if it is finished 6, 7, 8, then it will start. This is the given tabular column in that formula. See, first of all, we have to draw the predecessor diagram. This is the first step of line balancing problem. We have to take first one as a without predecessor. See here, already I told you, if there is nothing here, it is the starting stage of that particular station. So this is predecessor, this work is predecessor by nothing, and this also work predecessor by nothing. So it should be started first. Likewise, we have to draw the predecessor diagram. So this 1 and 2. This 1 will take a 0.2 minutes and this 2 will take a 0.4 minutes. See here that one work element and two work element without predecessor. So we are going to draw first for these two work element with the minutes 0.2. This 0.2 and 0.4, this one work element and two work element given by the problem. The table column is given. So we have to draw first these two. Then the next step is, see, now we are going for the table column. See here, this 3 work element number 3, which is predecessor by 1, and work element 4, which is predecessor by 1 comma 2. So what we have to do, see these 3 predecessor by 1 and this 4 predecessor by 1 comma 2. So this 3 predecessor by 1, this 4 predecessor by 2, which means 1 and 2. See here in previous column we will directly see 3 is 1 predecessor and 4 is 1 comma 2 predecessor, and 5 is only 1 predecessor. Likewise we will draw this 3, 4, 5. It is has a 1 predecessor, it is has a 2 predecessor, which is 1 work element and 2 work element, and this 5 have a 1 work element which is 2. Simultaneously we will write about the minutes. This 0.3 minutes and 0.1 minutes, 0.7 minutes we will write. Then we will go for that another work element number 6, which is predecessor by 3, and 7 also predecessor by 3, 8 predecessor by 3 comma 4. So we'll draw like this. 6 have only one predecessor and 7 also have only one predecessor. This work element 8 has two predecessors. One is 3 and one is 4. See, this work element number 8 have 3 comma 6. So this 3 comma 4, it is the predecessor of 8. Likewise, we will draw another column. See here the one, you can say what all the predecessor given here, this 6, 7 and 8. Work element number 9 have 3 predecessor. We'll go and check in that tabular column. See here 9 description have a 3 predecessor, 6, 7, 8. Likewise, we'll have a 11 with the predecessor of only 9, and 10 will have a predecessor of 8 and 5. Likewise, we will draw the diagram. Then finally, we will have that one a work element which is 12. See, this 12 we will have only one predecessor which is 11. So in that line balancing problem, this is the first step to draw the predecessor diagram. How we draw this diagram? With the help of that given table. From this table we will going to draw this predecessor diagram. This is the first step of that line balancing problem. We'll have a predecessor means we will draw according to like that. If there is a no predecessor means we will take as those predecessor, those work element as a starting. We will see the next step in the next videos. Thank you.